So, good morning, ladies and gentlemen, on this bright and sunny Wednesday, April 1st, 2020. I hope you're all having a good April Fool's Day. Don't take your pranks too seriously, but also don't make them too silly. Well, anyways, I want to jump back into this as quickly as possible. I think my video yesterday dragged on a little too much. So let's just get into this. Yesterday we talked about what an imaginary number is, what a complex number is, and how we can write that out using i's or addition signs like a plus bi. That is complex. Remember, it's made up of a real part and imaginary part. And since that is barely readable on the screen, I think I am going to stick to writing, or I'm going to try to write with a pen here. Going to write in a black pen. Black shows it better on a whiteboard, but anyways, you can see that little mark I just made. But today we're going to be talking about adding, subtracting, and multiplying complex numbers together. So, if we have something like this that says 2 minus 6i minus a negative 8 minus 15i, what we have to remember is that we can only combine like terms. I's are going to go with i's, non-i's are going to go with non-i's. Just like I can't subtract this 6i and this negative 8 together because they're different terms. One has an I, one doesn't. So with that, I'm going to simply subtract, since that's my operation, this 2 and this negative 8. What happens when you subtract negative, ladies and gentlemen? That's right, it's the same thing as adding a positive. So, writing my equal sign once again, I apologize for this being sloppy. 2 minus a negative 8 is the same thing as 2 plus 8, which gives me 10. That 10 needs to lose some weight. Then I have this minus 6i minus a negative 15i. Once again, when you subtract a negative, it's the same thing as adding a positive. So that's a negative 6i plus 15i. Now a negative 6 plus 15 should be a positive 9. If I did my math correctly, don't judge me, I'm just a math teacher. So, my answer should be 10 plus 9i. Now that is a complex number. If you look carefully, you have that 10 as your real part and that 9 as your imaginary part, or the 9i. Now, as I say with my kids, let's make it a little bit harder now. If we look at this, it looks like a bunch of mess with a bunch of square roots, but this is still adding and subtracting complex numbers, because you can see that is going to be an imaginary number, and that's going to be an imaginary number. So let's just take a moment, make this easier by breaking down all these square roots. Nothing to have to do with the 3, because that's just a 3, so I'm just going to throw that 3 at the end. But let's go back to the beginning. Square root of a 64, well, square root of 64, that's an 8. No I, since there's not a negative sign there, so I can already tell I'm going to add my 8 and my 3, and that's going to give me something we'll find out in a moment. Now, the square root of a negative 16. Now, once again, since that's a negative, I normally can't take that square root, but if I separate that negative between a negative 16, between a 16 and a negative 1, I can rewrite that as the square root of 16 times I. I can do that same thing with this 400 here. That's the square root of 400 times I. How are you doing, Minerva? You're a cute little kitty, aren't you? Yes, we might have a cat joining us in a moment. Let me not forget my operations here. So, now once again, I have these real parts, these imaginary parts, and I just want to combine them. But let's see if we can break down those square roots even further. Square root of 16 is 4. So this is going to be 8 plus 4i 8 plus 4 i's, ha ha ha, puns. Anyways, minus square root of 400 is 20, minus 20 I plus 3. Gosh, this is not pretty. But we do the best we can with what we have. So, 8 plus 3 gives me 11 last time I checked. And 4i minus 20i is a minus 16i. So my answer for square root of 64 plus the square root of a negative 16 minus the square root of a negative 400 plus 3 should be 11 minus 16i. Remember, that's still within a real part and an imaginary part, so it is a complex number. Now, time for a check for understanding. Take about 5 seconds, pause the video, see if you can work these out on your own. I'll give you that time right now. My kids can tell you I definitely work with a timer and time. So, answer to my first one, well, it should be pretty easy. It's going to be 3 minus 4. When you add a negative, it's the same thing as subtracting a positive, so 3 minus 4 gives me a negative 1, which I do have as the first part of my answer over here. Got all my notes right here. And then a negative 7i plus a positive 3i, it's still going to be negative because a negative 7's larger than a positive 3. So I should have a minus 4i. Pretty straightforward. Alright, so for the second one, you do have to do some deciphering. Square root of 25, that's just a 5. Plus 10i, nothing you need to change there. Now be careful about this one. You still have a minus, a negative, so that's going to be adding a positive when you're done. Square root of 81, 9, so I've got a minus 9. And now when you minus a negative, that's the same thing as adding a positive. Now square root of 4, hopefully you had that done on your own. That's going to be 2i, because remember, you can separate the square root by making it a positive square root of 4i with I on the outside, and then you just do the square root of 4. Now, we take these individually. 5 minus 9 gives me a negative 4. I'm having a whole bunch of negative 4s. Interesting. Did not intend that. 10i plus 2i gives me a 12i. And is that what I had on my paper? Yep. Negative 4 plus 12i. Good job, ladies and gentlemen. Parents, if you're working as well. So, moving on to our final and our most important one, and probably the most tedious when it comes to steps, we have multiplying and dividing. Well, that's fib. I'm not going to do any division here. I'm only going to be doing multiplying complex numbers. Division with complex numbers, entirely different story. Entirely different operation. So, multiplying. We have to remember that I squared is equal to negative 1. All my answers today will have some form of I squared, but no test, no exercise, no book wants you to put an I squared in your answer. They want you to write it as a negative 1, from what we talked about yesterday. An I squared goes from an imaginary to a real number. So, if I have something like this, 3 minus 2i times 4i, if you see this, if you have two things in a parentheses, times something else in a parentheses, or just times something on the outside, remember your distributive property. I'm going to take this 4i, multiply it with a 3, and then multiply it with a minus 2i. Well, what's 4 times 3? 12. So I have 12i. And then 4i times a negative 2i, well, what's negative 4 times 2? Or other way, negative 4 again. Maybe I have a fixation on it. What's a negative 2 times a 4? You get the same answer. A negative 8. So I have a minus 8i squared. But Mr. K, you said we don't need to have any I squareds. That's right, ladies and gentlemen. You take that I squared and you rewrite it as a negative 1 with a multiplication. 12i, gosh, that is an ugly 12, minus 8 times a negative 1. Now, you could probably see, gonna just scratch that out, don't need that. You can probably see that this 12i hasn't changed, is not gonna change. And so that's just gonna be a 12i, but what is a negative 1 times a negative 8? Positive 8. Negative times a negative is a positive. Now that is our final complex answer. But Mr. K, that's not in the form of a plus bi, that's b plus bi plus a. Well, true, but remember, addition is commutative. It's the same forwards or backwards. I can rewrite that as 8 plus 12i if I need to. I don't need to, but I'm going to do it just to quell all your fears. Now, this one's a little bit different. I have 1 plus I times 2 minus 2i. As you can tell, I have 2 terms in a parentheses and another 2 terms in a parentheses. And boys and girls, that does mean I need to use my box method, or as you guys often tell me, the Punnett square. So as I write my Punnett square here, it is obviously not a square because it does not have equal sides or equal angles, but you know, I'm not a geometry teacher, not a problem. I have 1 plus 2i, and then 2 minus 2i. Now this is kind of small, I should have written it bigger, but we'll make do. 1 times 2 gives me 2. 2i times 2 gives me 4i. 1 times a negative 2i gives me a minus 2i. And then a negative 2i times a positive 2i is a negative 4i squared. At this point, you just combine your like terms. There's nothing to combine with that 2, so I just write the 2 out. But these two in the middle are like terms, so you combine them. What's 4i minus 2i? Well, that's a 2i. And then nothing is with that bottom, so that's a minus 4i squared. Now once again, I never want to see that. Or I never want to see that on a final answer on a paper. Instead, I want you to recognize that, hey, I squared is negative 1. So that's going to be 2 plus 2i plus 4. Because the I squared becomes a negative 1, the negative 1 times with the negative 4 gives you a positive 4. Combine your like terms, you have 6 plus 2i. Now, ladies and gentlemen, this stuff can get a little trippy if you make a mistake somewhere in. So if you notice that I made a mistake, obviously just leave a comment, leave a suggestion. My math is not infallible, but that is pretty much what I got as my final answer. Oh, no, see, I just made myself a mistake. I'm gonna have to stop and edit that. That is supposed to be an I, but I wrote a 2i. Let me see if I can just erase this real quick. Obviously jump to later in the video after I've not made this mistake. Maybe I can edit this part out. But then again, it should be good to see that, you know, hey, we are not perfect individuals. Students, why didn't you speak up and tell me that I made a mistake? Because this is a video, Mr. Kreitlein. Ah, good point. 1 plus I. If you heard that, that's my wife over there laughing. And 2 minus 2i. I was actually noticing that something was off about my work, but I just kept going forward. Alright, 1 times 2 is 2. 2 times I, 2i. Negative 2i times 1 is a minus 2i. And a minus 2i times an I is a minus 2i squared. Now, obviously the first part doesn't change, the second part, the last part does change, and so does this middle part. But if you have a minus 2i and plus 2i and you need to combine like terms, guess what? They are going to cancel each other out. So you have 2 plus 0i. Now, since that's a 0i, that's just 0. You don't need to write it. Oh, let me not forget my square down there. All right, that obviously goes away. And that changes this into a positive 2, so you have 2 plus 2. Your answer should be 4. Now, we are coming up on the end of this video. I am going to leave the check for understanding up, but I'll quickly just say, hey, this is the answer and that's that answer. If you want to go and double check it, obviously leave a comment, message me through the website. If you multiply these two together, you should get 10 minus 2i. It is both a real part and an imaginary part, which I do want to go back and talk about real quickly. Your answer in this one only has a real solution. It doesn't have an imaginary part. But these two multiplied together gives you 10 minus 2i, and this multiplied together after you break that down to a 5, parentheses 20 minus 4i, is going to give you 100 minus 20i. All right, ladies and gentlemen, this is the end of the video. Once again, leave a comment if you have any suggestions. Leave a comment if you want to see something explained more clearly. Didn't have any cats show up today. Yes, I'm talking to you, Nazgul. But hope you all are having a great Wednesday. Once again, stay safe during these perilous times, and have a nice day.